welcome to the Deep Dive. Today we're tackling something that really puzzles a lot of people about electric cars. It's this power paradox.
That's a good way to put it. You drive an EV, maybe for the first time, and it just feels incredibly responsive, right?
Absolutely. You touch the pedal and it just goes. Feels really powerful.
But then you look at the official registration, the paperwork, that decides your taxes.
And the power number listed there seems, well, almost laughably low sometimes.
Exactly. It doesn't seem to match the experience at all.
So why? Why does the law seem to treat these quick electric cars like they're much less powerful? That's our mission today. We're diving into this gap between the power you actually feel behind the wheel and the power number you end up paying taxes on.
And to do that, we really need to get clear on two key terms. There's the potenza omologata, let's call it the homologated or continuous power.
Right, the official one.
And then there's a potenza di pico, the peak power, which is usually much higher.
And I understand there's a specific rule behind all this.
Yes. The framework for this is largely set by an international standard. It's the European regulation ECE R-85. That's the rule book that dictates how these power ratings are measured, how they get certified, and really crucially, which number actually ends up on the official documents.
Okay, let's start there then. The official number, the one on the registration document that the government uses, continuous power. What exactly is that number measuring?
Right. So continuous power, or sometimes called net maximum power, it's defined in a very specific way by that regulation. It's the average power the motor, along with its battery and cooling systems, can consistently deliver over a full 30-minute period.
30 minutes, while holding the accelerator pedal completely down.
That's the test. Full throttle for half an hour straight.
Wow, that sounds pretty demanding. It's designed to push the system hard, isn't it?
It absolutely is. And here's the critical part, especially for EVs. That 30-minute test is essentially a thermal stress test.
Thermal. So heat is the limiting factor.
Precisely. For an older internal combustion engine, it could often run near its peak power for ages. But for an electric vehicle, pulling maximum power generates a lot of heat in the battery, in the motor itself.
Ah, I see. So the continuous power figure isn't just some arbitrary legal definition. It's actually tied to the car's ability to manage heat. It's a kind of thermal safety rating.
You've got it. That lower number reflects the maximum output the whole system, especially the battery management system, the BMS, can sustain without risking overheating damage or compromising the battery's long-term health or safety.
So the car is designed to protect itself, throttling back after an initial burst.
Exactly. It pulls back to stay within safe operating temperatures. That continuous power rating is the legally certified maximum for prolonged safe operation.
Okay, that makes sense for the official cautious number. But what about the power that gives you that instant acceleration, the fun part? Let's talk peak power.
Right. Peak power. That's the number that aligns more with what you feel. It's the absolute maximum power the motor can pump out instantaneously. This relies on drawing the maximum possible current from the battery, but, and this is key, only for very short durations. We're talking maybe just a few seconds.
So perfect for those quick bursts you need, like getting onto the motorway or overtaking someone quickly.
Exactly. It's a temporary surge the system can handle because it's not sustained long enough to cause thermal issues. It knows it will dial back quickly to the sustainable, continuous level.
And crucially, this peak power number.
Right.
It doesn't show up on the registration, does it?
No, absolutely not. That's a really important point for anyone looking into EVs. Peak power is not on the official registration document. You'll typically find that figure, the much higher one, buried somewhere in the manufacturer's technical spec sheets. Sometimes it's not even easy to find.
Okay, so this split personality, the sort of Jekyll and Hyde thing with EV power ratings, why is this mainly an EV issue? When I think about a traditional petrol or diesel car, we don't usually talk about two different power figures like this.
That's a great question. The fundamental difference is in how they deliver power and manage heat. For decades, with internal combustion engine vehicles or IC cars, the maximum power figure they advertised. Well, that was pretty much the power the engine could sustain, more or less.
You mean, if a petrol car said 150 horsepower, you could theoretically drive it using close to 150 horsepower for a long time?
Generally, yes. Within reason, of course. You might run out of fuel or eventually hit some mechanical limit, but the advertised peak power was much closer to its continuous capability.
So simplifying it.
Yeah.
For a gas car, max power roughly equals continuous power, and that single number went on the paperwork.
That's a fair summary. But EVs, because of those thermal limits we talked about, they just operate differently. For an electric car, the peak power potential is always significantly higher than its rated continuous power.
And that technical difference has big implications. The car uses the high peak power for performance, for that acceleration feel.
Right.
But the legal and tax side of things only cares about the lower continuous power rating, that 30-minute average.
Exactly. That's the number used for classification, for insurance groups sometimes, and definitely for taxation in many places.
Right. This is where it gets really interesting, isn't it? Connecting the engineering back to your wallet. I mean, shouldn't the real performance number be the official one? It almost sounds like manufacturers are, maybe legally, but still sort of gaming the system.
I can see why you'd say that, but you could also see the ECE R-85 regulation differently. It's not really defining performance in the way a driver feels it. It's defining sustainable output. And by setting that official bar based purely on the tough 30-minute continuous test, the regulation actually creates a pretty significant economic advantage for the EV owner. Well, it lets car makers deliver that really satisfying temporary performance, the instant torque, the quick zip off the line without sticking the owner with the higher taxes and potentially higher insurance costs that usually come with a car rated at that higher power level.
So it kind of optimizes the car for how people actually use them, especially in cities. Lots of short bursts of acceleration, not many 30-minute flat-out runs.
Yeah.
And it does that without the financial penalty.
Precisely. You get the practical performance benefits without the traditional financial downsides of high horsepower on paper.
Okay, let's make this really concrete. You mentioned the Renault Twingo Elettrica as a good example.
Yes, the Twingo EV is a perfect case study for how this works in practice. If you check its official registration documents, the Potenza Continua Omologata, the continuous power, is listed as just 31 kilowatts.
31 kilowatts. Okay,
Yeah.
converting that, that's around 42 horsepower, right? 42 CV.
Exactly, 42 horsepower. Which, on paper, for a modern car, sounds incredibly modest, almost like a small motorbike or a scooter. That's the number the tax authorities are looking at. But if you dig into Renault's technical specifications, you find the Potenza Massima, the peak power figure, and that's 60 kilowatts.
60 kilowatt peak. Okay, what's that in horsepower?
That translates to about 82 CV, or 82 horsepower.
Oh, so it officially looks like a 42 horsepower car, but when you actually accelerate, it's delivering almost double that, 82 horsepower.
That's it. So look at that. The Twingo EV is fiscally rated exactly where the base Fiat 127 was decades ago, around 42 CV.
But when you put your foot down in the Twingo, you get 82 CV peak. That's significantly more punch than even the sporty Fiat 127 had back then.
Absolutely. And think about how you got the power in the Fiat 127. You had to rev the engine high, work the gearbox.
No.
It was noisy, maybe a bit vibey, and the power built up gradually.
Right, you had to work for it.
Whereas the Twingo EV, it gives you that 82 horsepower peak pretty much silently and instantly thanks to the electric motor's torque. It just scoots away from traffic lights.
Yet when the tax bill comes,
You're paying based on the 42 CV continuous rating, the thermal limit number, not the 82 CV you actually use for acceleration.
let's quickly touch on top speed, though, just for fairness. The Fiat 127 could manage maybe 135, 140 kilometers per hour.
Something like that, yeah.
And the Twingo EV, its top speed is limited to around 135 kilometers per hour.
That's right. And that similarity in top speed is actually quite telling.
How so?
It shows that ultimate top speed depends on more than just raw horsepower. Aerodynamics, gearing, weight, they all play a huge role, especially in small cars. But the way you get towards that top speed, the acceleration, the ease of driving, that's where the EV's peak power makes a world of difference compared to the old Fiat 127, even if their continuous ratings and top speeds look similar on paper. The Twingo gives you that 82 CV burst when needed, making it feel much more capable in normal driving, while staying fiscally modest at 42 CV.
Okay, it's much clearer now. That number on the EV's registration, the 30-minute continuous power figure, it's really just a baseline. It's the legally defined minimum for sustained use, dictated mostly by heat management.
Exactly. It was never meant to represent the car's sprinting ability or that immediate feeling of power.
And this distinction, this focus on continuous power in the regulations, it seems to perfectly suit the strengths and weaknesses of current EV tech, especially for city cars.
It really does. Manufacturers can leverage that ECE R-85 focus on sustained power, something EVs are inherently limited in compared to their peak output, to keep the official taxable power rating low. But at the same time, they can maximize that short burst peak power, which is precisely what makes driving in urban environments feel effortless and responsive.
So the regulation itself almost encourages this type of design
Yeah.
because the rules focus on that 30-minute endurance test.
Mm-hmm.
Engineers have an incentive to create systems that deliver fantastic temporary power, knowing that this peak performance won't lead to higher taxes or registration costs associated with that higher number.
That's a really insightful way to look at it, yes. It raises a fascinating question for the future, doesn't it? How does this specific regulatory approach fundamentally shape how performance is designed, valued, and even marketed in modern cars?
Hmm.
Because the legal framework allows for this high feeling of performance while classifying the car officially as low power, it makes the EV an incredibly smart choice for city use, efficient on paper, efficient for your wallet, and surprisingly zippy on the actual road.
A brilliant summary. The power you feel versus the power you pay for the EV power paradox. Explained. This has been a fascinating deep dive.